There's a planet in our galaxy that scientists are really excited about. In fact, it's the closest Earth-sized planet outside our solar system. It's probably rocky and could have liquid water flowing on its surface, an essential ingredient for life. There's only one problem. We can't actually see it, and it's impossible to get to. To get to Proxima Centauri b, it would take a spacecraft over 75,000 years to travel there with today's technology. Even powerful ground-based telescopes can't see the planet in any detail, mostly because it's being drowned out by the light of its star. This raises the question, how do we investigate a planet that you can't see and you can't get to? This supercomputer is tasked with running sophisticated climate models to predict Earth's future climate.
It's loud, you can feel air rushing by, you can feel a hum in the room. It feels powerful. It's one of the most powerful supercomputers in the world.
And now, it might be scientists' only hope for discovering whether any of these newly discovered planets could possibly sustain life. Last year, a team at NASA Goddard Institute for Space Studies in New York City decided to investigate further. What happens when you take a possibly rocky planet situated in its solar system's habitable zone and simulate hypothetical climates based on the only planet we know of with life, Earth? We only know basic details about Proxima Centauri b, its size, mass, distance from its star, and the type of star it orbits. And that's it. Right out of the gate, Proxima b has some problems. It's 20 times closer to its star, Proxima Centauri, than Earth is to its sun. This means that it's likely gravitationally locked to it, just like the Moon is gravitationally locked to the Earth. As a result, one side of Proxima b always faces its sun's intense radiation, while the other freezes in the darkness of space. But slap on a hypothetical atmosphere on the planet and fill it with an ocean, and Proxima b virtually comes alive. Here's where this gets interesting. We're looking at the side of Proxima Centauri b that's facing its star, so it's the warmer side. In the simulation, the modelers gave the planet a global ocean. The ocean circulates heat around the planet through ocean currents that are produced by the planet's rotation, just as we see on Earth. The ocean current actually carries warm water to the side of the planet without starlight and up towards the poles. This creates a characteristic pattern of ice-covered ocean, similar to our own North Pole, versus ice-free ocean, a pattern we would see on any rotating ocean-covered planet. In this simulation, modelers use Earth's continents as a stand-in to predict what would happen if most of the land was on the side of the planet facing away from its star. How much land might be covered in ice, and how might ocean currents interact with land masses when transferring heat? Conversely, if most of the continents face the warmth of its star, how much incoming radiation would actually be absorbed by the ocean, and how could this affect the planet's dayside and nightside temperatures?
So those are some of the tricks we play. We give it different kinds of atmospheres and see how the planet responds, the climate responds to that, because we really want the planet to be in what we call the habitable zone, where it would have liquid water on its surface. And so that's the game we play.
Scientists are finding these exoplanets could actually have ingredients to support life under a range of surprising conditions compared to Earth. Is it possible that our notions of what make a planet suitable for life are too limiting? Had alien civilizations pointed their telescopes towards Earth billions of years ago, expecting to find a blue planet swimming in oxygen, they would have found a much different world.
We definitely look at Earth through time. We might try different topographies, different land sea masks. For example, the topography we have today on Earth is not the topography Earth had 250 million years ago.
With money and time both limited resources, scientists are looking for the most promising planets to point their observatories at. Proxima Centauri b may offer a blueprint for what to look for in a planet in the near future.